Hi, Fox. Alright, we are going to talk about the standard normal distribution and Z-score. So this is primarily under the statistic. Of course, this is also included in our data management topic, just like what we are dealing with previously in our lesson. And so I will going to introduce you first those notations that you're going to encounter. So this notation here is the standard notation in our given distribution, which is showed by or represented as n parenthesis mu comma sigma. And a mu is the symbol for mean, and our sigma here is symbol for standard deviation. In this diagram, alright, yeah. So we are going to also use this formula for finding the z-score. So as I mentioned, our topic will be focusing on standard normal distribution and z-score. So this will be our formula for finding the z-score. Z-score is equals to x, which is the presented individual score, minus mu is our mean, divided by the sigma standard deviation. As you can see here in the diagram, this is normally distributed or a bell-shaped distribution. That is the so-called normal curve. And in our normal curve, the center will always be the mean here. And this spread here is our standard deviation value. So when we are going to use the formula, this will be our new value in our standard normal distribution. Okay, so this is presented when we have a problem representing a raw score or somewhat like x, and then we are going to use this formula in order for us to arrive at this standard normal distribution. Okay? Parehas din siyang normal, pero ito yung pangalawang curve, itinatawag nating standard normal distribution. Here. Right? So this is the so-called standard normal distribution, wherein our mean is equals to 0, as you can see, and the standard deviation is equals to 1. The range of values of our z-score here in our standard normal distribution will be approximately from -3 to approximately +3. So today we will learn how to apply this formula and make use of the standard normal distribution diagram in some of our problem given in this lecture. Alright, so let us take a look and continue this one. Again, our formula for finding z-score will be x minus sometimes represented as mu, or the mean, over sigma, or divided by the standard deviation. So this is the formula used to standardize a given value of ax using the mean and standard deviation. For example, here in our normal curve, given the mean here will be 37, and our normal and our standard deviation is 5. So our mean is 37 and our standard deviation is 5. And what is the raw score here? Raw score will be this one, 43. So mean will be 37, ST is 5, and our X is 43. And by direct substitution, we're going to use the formula Z is equals to the X, which is represented by the individual score of 43, minus the mean, which is 37, divided by our ST, something I forgot to put it, ST, or the symbol that we can sometimes use is the sigma for standard deviation. And then we are going to substitute those values here. So z is equals to 43 minus 37 divided by 5 is equals to 1.2. And in order for us to see where the 1.2 in our standard normal distribution, let us plot like you're plotting a number line in a graph or graphing it. So on the left side of our distribution will be those negative values, and on the other side will be those positive values. Right, so as you can see here, we're going to estimately plot the 1.2 here. So 1.2 will be here, and as I mentioned, when you are plotting a standard normal distribution, the mean will always be equals to 0 here. Alright, so that's it. And then we are not only ending on this part, because this computed 1.2, yeah, this is the z-score, but sometimes in our problem we are prompted to compute for the percentage itself, for the percentage of the z-score. So we can be able to use the standard normal distribution table. So as you can see here, our z is 1.2. So let us take a look on the standard normal distribution table. Alright. This standard normal distribution table, we cannot see 1.2 here because it starts from 0 point something. And here, just take a look at 1.2 values here. This means this one, our z is 1.2. It means that our percentage value will be the 0.3849 or 38.49%. So when you are asked what is the percentage of this z-score, you're just going to use the standard normal distribution table. And no worries, because I will going to provide naman this table when you are going to take your exam, so you can take a look. Alright, you don't have to remember all of this. This will be given to you on our exam. So 1.2 will lie on this part. Okay, so meaning our percentage for the z-score 1.2 is 38.49%. And aside from that, we have also those values like 2 point something up until the approximately 3.0 here. So when say for example our computed z-score is 2.36. So we have 2.3 here, and just take a look here on the what column. The next what is the next column, provided this row we have 2.3 and we're looking for 2.36, so it will lie here and then it will lie here. So our percentage value will be 0.4909 or 49.09%. Say I would like you to get the percentage of the z-score value 2.88. Okay, so we have 2.8 here and then 0.08 here. Just take a look here. Okay, so what is the intersection here? There's 0.4980. So it means the percentage for the z-score 2.88 is 49.80%. So you are going to learn all about this when we are going to tackle the next example here. So we have this problem. Suppose that IQ score have a bell-shaped distribution with a mean of 100 and the standard deviation of 15. What percentage of people should have an IQ score between 85 and 115? So yeah, in this kind of example, given problem, we are going to compute and find out what will be the percentage of our z-score. So given this kind of distribution, we're just going to plot first. Our standard deviation will be 15 according to the given, and then our first x will be 85, so it will lie here, and then our second x will be 115, and then again our mean will be 100. So we're going to get the area of this part. Okay. How are you going to do that? Just use this formula. Z is equals to x minus mu over sigma, or x minus mean over standard deviation. So just substitute, we have 85 as our first x here, minus 100 all over 15. So 85 minus 100 is negative 15, divided by 15 is negative 1.00. And now we're going to compute now for the z-score of this x sub 2, which is 115. Alright, yeah, we just plotted this one here, okay? And yeah, we're going to move forward now here in x sub 2. Just substitute again, 115 minus 100 divided by 15. And then 115 minus 100 is 15, divided by 15 is positive 1.00. So if we're going to plot this one, so z is our 1.00. And we are going to apply right now the standard normal distribution table. So we're going to look on the value of 1.00 under standard normal distribution table. And don't you worry, when you get negative values, it's okay. It is somewhat similar like when you are getting the percentage of 1.00. So when you get the negative values, again, when you get the negative values, just get the absolute value of it and then apply it to the standard normal distribution table. So in our standard normal distribution table here, let us take a look on 1.00. So 1.00 will lie here. It means our percentage will be 0.3413, meaning we have 0.3413 and this left part and 0.3413 in the right side. We're just going to add this two in order for us to get the area of inside this. Okay, so 0.3413 plus 0.3413 is equals to 0.6826 or 6826. And just get a percentage. So move our decimal point to the right twice or two times. So we have 68.26%. So this will be our final answer. Let us now take a look with other example here. Suppose that IQ score have a bell-shaped distribution with a mean of 100 and the standard deviation of 15. What percentage of people should have an IQ score between 70 and 130? As you can see in this given problem, it is somewhat like similar with our previous example. So again, we are going to get the area for this percentage area. And yeah, our standard deviation is given will be 15. Our first x, our first raw score is 70. Our second raw score is 130. And our mean is 100. So first, we are going to compute in our x sub 1. Just substitute 70 minus 100 divided by 15. And 70 minus 100 is negative 30 divided by 15 is negative 2.00. So this will be the value for our z-score. And then when we are going to move forward right now in the x sub 2, just substitute using the given formula here, right? So we have just plotted this negative 2.00 again here. And yeah, let's move forward to x sub 2. We have z is equals to x minus mean divided by standard deviation. 130 minus 100 divided by 15. And 130 minus 100 is 30 divided by 15 is positive 2.00. We're just going to plot it here for our z. And yeah, so you have a clue as well. We're going to get the percentage of this z-score 2.00 and we're going to get the total of those two, or we're going to sum it all. So we're going to use now the standard normal distribution table. Well, 2.00 is this. So we have 0.4772. So when we are going to plot it here, we have 0.4772. We have two values of this. And then we're going to add 0.4772 plus 0.4772 is equals to 0.9544. It means our percentage score will be 95.44%. You're just going to move the decimal point to the right side of this value 2 times. So yeah, here is will be our final answer. And let us now move forward to the third problem. Suppose that IQ score have a bell-shaped distribution with a mean of 100 and the standard deviation of 15. What percentage of people should have an IQ score more than 130? So take note of that. We are computing for a score that is more than 130. So first we are going to illustrate this in a diagram. Our standard deviation is 15. Our x sub 2 is 130. And then our mean is 100. So it's okay if we don't have any value in x sub 1. We're just going to move forward and let us compute using the formula for z-score using this raw scores of 130. So z is equals to x minus the mean over standard deviation. So we have 130 minus 100 divided by 15. And 130 minus 100 is 30 divided by 15 is 2.00. And this portion right now, we are going to use the standard normal distribution table again to get this value. So yeah, 2.00 will lie here again, 0.4772. Just put it here so that you will not be confused. So we have 0.4772. And as we mentioned, we're just going to take a look what is the percentage of people should have the score more than 130. Not this 130, but this 130. More than. We're going to look it for more than 130. And since we have only one value of our raw score that lies on the right side, then it means that on this distribution, this half is equivalent to 50% or 0.5. And again, we're just going to compute for this portion only, as you can see. We're just going to subtract this computed value came from our standard distribution table. Just subtract this from 0.5. So 0.5 minus 0.4772 is equals to 0.228. So it means that 0.228 is the value of this portion. That's what we are looking for, the score more than 130. Okay, and then just move again 2 times the decimal point to the right side of this value. So we have the final answer, which is 2.28%. Okay, so don't be confused regarding with the problem. All right. So right now we're going to move forward and illustrate and find the area under the standard normal distribution curve. Given only some basic information. So to the right of z is equals to 1.38. So we're just going to take a look what will be the percentage area that is to the right of the z that is equals to 1.38. So we don't have to use the formula here. We're just going to estimate and take a look how we're going to illustrate this. Given the z will be 1.38, or this spread is 1.38, and we're going to get the area of this part because it mentions here that we are going to get the portion to the right of our z. Okay, but if ever it mentions here that to the left of z is equals to 1.38, so we're going to get the area of this portion, the left value of 1.38, right? So solution, just get again our standard normal distribution table. Let's take a look where will be the 1.38 lies. We have 1.3 and 1 and 0.08, and we will across here. It means our value coming from the standard normal distribution table is 0.4162. Okay, let me erase this one and put it here, meaning we are going to subtract this from 0.5 because we are just using the half of the normal distribution illustration here or diagram. So 0.5 minus 0.4162, so meaning our x greater than or equal to 1.38 is 0.0838, and convert it into percentage. So we have the final answer, which is x is greater than or equal to 1.38 is equals to 8.38%. Alrighty, so let us take a look next on our second example for illustrating and finding the area percentage of the z-score. So between the z is equals to 0.32, so this is 0.32, and then z value is negative 1.32. So between, it means sa gitna ng dalawang values ng z natin. So it means we're going to get this. Alright. And yeah, for our solution, let us take a look first on our given standard normal distribution and find out what is the value for 1.32 z-score. So we have 1.3 and then 0.02. It will lies here, 0.4066. Alright, yeah. And then we are going to add it with the value of our z-score 0.32. Just take a look again on the table for 0.32. For 0.32, our given value is 0.1255. So we're going to add this because we are getting the area in between of this two z-score 0.32 and negative 1.32. So meaning 0.4066 plus 0.1255 is 0.5321. Mean our percentage will be 53.21%. Okay. How about when we have this kind of problem? To the right of z is equals to 0.29 and to the left of z is equals to negative 1. Let us illustrate it first. So we have 0.29 here in this part, and then this will be the portion that we are looking for because it mentioned that we have to the right of this z 0.29, and when we have z is equals to negative 1, it mentioned here to the left. Alright, so just shade this one so that you will not be confused. Meaning we're going to get the area percentage of this two. Okay, since we have already again two values, meaning we're going to get the sum of this when we already found the value from the standard deviation table. But I will also inform you that we use the whole part of our standard normal distribution. So in this time, we are going to subtract the sum of these two areas by 1. Right? Because we already used 100% of our standard normal distribution diagram here. Yeah, so approximately we have 0.29, x we're looking for x. X is less than or equal to -1 but greater than or equal to 0.29. As I mentioned, we are going to subtract the value that we found out on the table from 1. Why 1? Because we've used this part and this part. We've used both part of the distribution, meaning we've used 100% of the distribution. So we're going to subtract those values that we are going to look for from the table from 1 or from 100%. First, of course, we are going to take a look on the value of 0.29. 0.29. Oh, first, the 1 point, let me just go back. 1 point, or -1. This one, -1 and 0.29. That's what we are looking for in our table. Okay. Okay, for -1, this is our value from the table, which is 0.3413. And for the 0.29, we have this 0.2 and 0.9. We'll pause it here. Meaning our value for 0.29 will be 0.1141 according to our standard normal distribution table. And we're gonna put it here. So we're gonna add those two values and then subtract it from 1. So 0.3413 plus 0.1141 is 0.4554. So 1 minus 0.4554 is 0.5446. And when we move the decimal point to the right side of this value, we're gonna get this percentage of 54.46%. So this will be our final answer right now. When you get the area percentage to the right of z is equals to 0.29 and to the left of z, which is -1. Okay, that will be all. And I hope you enjoy watching. Thank you so much. Bye-bye.